Instead, they can look at the video or watch the video. Okay. Chapter 4, Section 6, completing the square. We're going to be doing this most of this week. Okay. This is just the intro. Okay. You need to understand today in order to be able to go tomorrow. Today's not hard. You can grasp today. Everybody in here is able to get today. Okay. Solving equations by finding square roots. That's what we're going to do first. What is the opposite of a power? It is a root. Okay? For example, what I mean by that is, what's the opposite of addition? Subtraction. What's the opposite of subtraction? Addition. What's the opposite of multiplication? Division. Division, multiplication, right? Yep. The opposite of a power is a root. If you have a squared, the opposite is a square root. And there's a little imaginary 2 in here. If there's no number here, that means it's a square root. Okay, you'll see what I mean here in a second. Okay, the opposite of a square root is a squared. They're going to cancel out, and you're going to be left with x. If you have cubed, obviously a square root is not the opposite of a cube. What do you think it's called?
Cube root.
A cubed root. Okay, a cubed root. Whoops, not that. Cubed root. And there's a little 3 right here, so you know it's a cube root and not a square root. Opposite of cube root, what do you think it is?
Cube.
Cube. Okay, this is just going to give me x. They're opposites. Opposite, opposite, opposite. So in order to get rid of a squared, you have to square root it. In order to get rid of a cube, you have to cube root it. In order to get rid of a cube root, you have to cube it. Okay, there's opposites. How do you get rid of them? You just do the opposite. So let's do that. Let's solve some equations with squares in them. So if I solve this equation now, get out of factoring. Okay, just go into solving equations. Go out of factoring mode. How would I solve this equation if I was just solving for x?
Subtract 10.
Subtract 10 to both sides. Okay, so go ahead and do that. So I'm left with 4x squared equals 36. What's the next step?
Divide by 4.
Divide both sides by 4. I have x squared equals 9. How do I get rid of the squared? Square root. Now, what is the square root of 9? 3. 3 times 3 is 9, right? Good try. Okay, so I have x equals 3. Now, that's almost right. What's wrong with that answer? Positive or negative, right? Plus or minus. Can't you have negative 3 squared and it still gives you 9?
Yeah.
You could have 3 squared and it gives you 9. So you need to make sure to understand there are 2 answers, plus or minus 3, and that's how we draw it. Okay, there's a plus sign on top and a minus sign on the bottom. That stands for plus or minus or positive or negative 3. Understand that?
They can equal the same thing with a positive.
Negative. There's 2 answers. Because if you think about it, if I have x squared, how do I get 9? Well, I could have negative 3 squared, or I could have 3 squared. So there's 2 possible answers to have a true statement. Okay, so you need to remember that when you're square rooting. Oh, I have 2 answers, not just 1. Okay, so let's look at this one. Let's solve this one. Okay, add 5 to both sides. So I have 3x squared equals 30. Next, Joseph, what do I do? Divide by 3. So I have x squared equals 10. What's next, Autumn? Yep, the little check mark guy. What's it called? The root. Square root. Very good. Okay, what's the square root of 10? A really ugly looking decimal number, right? What times itself gives you a really ugly, or gives you 10? It's not 5, because 5 squared is 25. Okay, so guess what I want you to put for your answer? Leave it like that for right now. Tomorrow I'm going to tell you what to do after that. But for today, I want you to just leave it like that. Any questions? So So far. Here's what I want you to do. I want you to do this one all by yourself. See if you can come up with the right answer. First thing I do, subtract 9 from both sides. So I have 2x squared equals 4. Divide by 2. X squared equals 2. Opposite of squared is square root. These are going to cancel. I'm left with x equals plus or minus square root of 2. So positive square root of 2 or negative square root of 2. Two possibilities. Good? So far? Good. All right. Now, completing the square. I need you to understand that we're completing the square because, well, I'll explain that why later, okay? But when you complete the square, here's why we can complete the square. Because we can use it to find the following things. Number one, we can find the vertex of a parabola. The vertex, if you remember, is either the lowest point in a regular U or the highest point in an upside down U. Remember that vertex is the highest point or the point where it starts? Okay? When we complete the square, it's going to help us find that. Okay? Factoring completely, it's going to help us factor things completely, things that can't be factored. Okay? For instance, when you took your factoring test, those are all things that worked. Sometimes you have x squared plus 2x plus 2, and it doesn't work, equals 4, and you can't factor it. You can't put x minus 1, x plus 3, you have to, it doesn't work. Well, guess what? Completing the square helps you solve those. Okay, helps you figure that out. And defining x-intercept. What's an x-intercept? What's that?
Opposite of the line intercept is where it crosses on x.
Where it crosses on the x-axis. Where the graph hits the x-axis is whenever y equals 0. Okay, your points when y equals 0, where it crosses that x-axis. Okay? When can you use the method called completing the square? You can only use completing the square when you have a degree of 2. What is degree? Who can remind me what degree is? What's degree, Sky? You don't want to?
It's like angle.
Yeah, you're thinking geometry. Yeah. That's one definition of degree. I'm looking for the algebraic definition of degree. Algebraic. Does anybody remember what degree is?
Yeah, I have no idea.
It's the highest power. Okay, so if I have x cubed, what's the degree? 3. Okay, or if I have x, y, degree is 2, because I have x to the first power, x, y to the first power. Question?
You can't do it with x to the 3.
Right. If you have x cubed, you cannot complete the square. Okay? You cannot complete the square in x cubed. You can only do it when there's a square. Do you understand? You need to understand that. Only when you have x squared. Only when degree 2. Now, possible answers that you're going to get when you complete the square. You can have rational answers, and you can have irrational answers. Let's talk about the rational answers. Any number that you can write as a fraction. So 3/4, 5, 12 over 5, 4 1/4, which is 17 1/4. Anything that you can write as a fraction is a rational answer. An irrational answer, what cannot be written as a fraction? Who can think of an example of irrational? 5. We just wrote one down earlier.
The square root of 10.
Square root of 10. Square root of 2. Right? You plug that into a calculator, you're going to get something ugly that cannot be written as a fraction. Okay? Yes. Square root of 2. Square root of 10. Irrational answers. So let's go back to our answers that we got. Our answer here, in this example, irrational or rational? Irrational. Up on top, irrational or rational? Agreed. Rational. On the bottom, irrational. You understand the difference? Okay, you can write. We can't write square root of 10 as a fraction. Okay, so it's an irrational answer. If you plug square root of 10 into a calculator, What in the world do you get? Let's figure it out. Do I have a square root here? I doubt I do. No. Oh, where's my TI Inspire? Because it has a square root. Alright. Let's look what we get, if I can get this ever to come. Okay, square root of 10. Control. Oh, we need a calculator first. Square root. That's what it gives me. We'll watch what happens. Square root 10. Okay, and it goes on forever. Okay, it's not, I don't think that is the answer for real. I think it just keeps going and going and going and going. Okay, is that true? Can you plug it in? Yeah. Okay, you can't write this as a fraction. Okay, just like you can't write pi as a fraction. Any questions about irrational rational? All right, let's move on.
Which one's is that irrational? The number
What's that?
the number keeps
Yes.
going on is irrational.
Yes. Cannot be written as a fraction. For instance, 1/5 can be written as a fraction, or a decimal, 0.2. It ends. 0.2 ends, right?
What if it's like a third?
0.3, like that. Can 0.3 be written as a fraction? 0.3 repeating can be written as a fraction? 1/3, so it's a rational number. Does that make sense? If it can be written as, it's rational. If it can be written as a fraction, it's rational. If it cannot, it's irrational. Like 22 divided by 7, irrational. Or no, I'm sorry, not irrational. Rational is the closest thing to pi as a fraction, but it's not pi. Anything that can be written as a fraction is rational. If it cannot, it's irrational. Okay? So if you say 22 over 7, it's rational. Okay? Or 1/3, it's rational because it's a fraction. Okay?
Okay.
Leading coefficient, the number in front of the x squared. Okay, the number in front of the x squared. I look at this equation, 4x squared plus 2x minus 3 equals 7. What's my leading coefficient? It's the number in front of the x squared. It's 4. Okay, in this one, okay, if I have x squared minus 4x equals 6, what's my leading coefficient? 1. So if I ask you in the equation, what's the leading coefficient, you should be able to look at it, look at the x squared, find the number in front of it, that's your leading coefficient. Okay? Now, here is completing the square formula. Okay, I'm going to come back to this, and you're going to have to use this in just a second. Okay, but first we're going to talk about what the heck is going on. All right, some of you guys have names. Okay, for instance,
Let's hope.
let me think of somebody. Okay, Joseph, for example. Joseph can be, we can call Joseph Joe, Joey, Joseph, or Joe's, I don't know. Bunch of different forms of Joe, Seth, right? Okay? Same thing as Will, or William. Okay? Do you see how there's a lot of different forms of the name William? Okay? Some people prefer, they don't want to be called Bill, or some people don't want to be called Joe, or whatever the case is. That's fine, but do you see how all of those names are forms of the original name? And it's the same person. All of those Joes that I just said, or the Josephs that I just said, that means I'm standing for this guy right up front, right? Okay? Just like my equations here. These are all the same thing. They're just written differently in different forms. This is basically the same person, it's just written in different forms of his name. Okay? I need you to understand the relationship, because x plus 3 squared, isn't that just x plus 3 and x plus 3? It's not written the same, but it means the same thing. You see that?
Yeah.
This, how did I get from this form of Willie to this form of Will?
Just not.
I FOILed. Yeah, you FOILed to get from here to here, right? I took x times, or I'm sorry, x squared times x plus, or x plus x, x times x, excuse me, x squared, plus 3x, plus 3x, plus 9. And I got Will, didn't I? How did I get from Will to Bill?
On foil? Or no? Completely.
I combined my like terms.
Yeah.
Okay, I took 3x and added it to 3x and I got 6x. Okay, I just combined these two. All mean the same thing. Okay, all written differently and they look completely different basically, for the most part. Now, when you complete the square, I'm going to teach you how to take Bill and rewrite it as William. Does that make sense? I'm going to give you this, and I'm going to teach you how to write it like this in 1 or 2 steps. Okay? And that's the equation that's on the top of that notes part. Okay? For example, this one is already written as Bill, and we know how to write it as William, but how did they do that? Okay, let me show you. You take the B coefficient. In this case, my B is right here, the one with the X in front of it. What is it? 6. You're going to take 6 and divide it by 2 and then square it. 6 divided by 2 is 3. 3 squared gives me what? 9. Now, look at your formula that I gave you. Completing the square. To write it as William, what do I have to use with the B? What do I have to do to the B to write it as William? Look at that formula. This is William right here. How did they get this number right here? How did they get this number? They took 6 and divided it by 2. Okay, that's all they did. To get it written in William form, you take x plus whatever your b is, divided by 2, and that's squared, and that's William form. That's it. That's how you go from Will to William, or Bill to William. Okay, so my b is 6, so it's this green part inside the square. It's this one right here. That's what goes right here. And that's what they got, x plus 3 squared. If you're still confused, that's okay. We're going to show you another example here on the next page. Okay? Now, complete the square. If I have x squared plus 16x plus blank, how do I get that third term? How do I get that constant term? What do I have to do? 16 divided by 2 squared. Well, that gives me 8 squared, which gives me 64. How do I write that as William? It's this number that you squared. It's the b divided by 2. It's the b term divided by 2. Okay? I took the b term. This is my b term. I put it inside, divided it by 2, and squared it. That's how I got my William form. This is written as Will. It's the same thing. If I would write this x plus 8 times x plus 8, boil it, combine it, I would get that. Okay, or that's Bill, not Will, right? In your homework, or in your notes, sorry. You understand how I got it? You take your b term, divide by 2. Let's do another one. How do I get that blank? Divide by 2 and?
Squared.
Right, b divided by 2 squared. Gives me the square part. So I take 14, divide by 2, squared, 7 squared, 49. Put in your 49. Now, how do I write it in William form? Take your b term, whatever it was that you divided by 2, which is 7, and put it in here. Are you with me? Not hard so far. Not bad. Take your b term, divide by 2, square it to complete the square, put it inside. Get your William form. Now, do one more. See if you can do it by yourself. All right. How do I get my complete the square? What do I know? What do I have to put in here? I take negative 18, divide by 2, squared, negative 9 squared gives me 81. What is my William form? Be careful. X minus 9. Not plus 9. Don't forget, you have to use that negative sign.
I just have plus 2 on mine. Where?
Oh, word. It has to be a negative. Okay? Now, the next question. How can I rewrite the equation x squared plus 12x plus 5 equals 3 in the form of William, x plus a squared? This is number 10 of your homework. I am not going to tell you the answer today. Okay? I am not going to tell you how to do it. I want you to think about it and put your best guess in there. Now, if you could factor this, that would give you the answer, wouldn't it? You could set it equal to 0 and factor it out, but it doesn't work. You're going to have to complete the square.
Can you still set it out to be 0? I mean,
okay, try it.
Wait, I have a question. Can we get rid of any numbers though?
You can do whatever you got to do. That's
The
true.
only time you can get rid of that 5.
So what do you want to do?
Get rid of that 5.
How?
Subtract it out.
Okay. Go with that and see where you get.
That's probably not gonna give me anywhere.
Go with that and see what you get. Okay? I'm not going to say anything more. We're gonna do this on Wednesday. Okay, tomorrow I'm going to teach you just a little part how to rewrite your answers, and then Wednesday we're going to keep going on completing the square. Okay, so I want you to think about this. I wanted to point this out because I didn't want you to read number 10 and be like, what in the world? I wanted to make sure you've seen it before. That way when you see it, you're like, oh yeah, okay, I saw this, let me see, what would I do? Start thinking like a math person and say, how would I be able to factor this out to write it like William to find the solution? Okay? Question. Did you have a question?
No.
Okay. Your homework is right here. I probably do somewhere.